Bhavesh Patel, thank you, is Associate Research Professor at the California Medical Innovations Institute, a nonprofit biomedical research institute located in San Diego, California. He completed his PhD in mechanical engineering at the University of California, Berkeley, where he specialized in computational modeling. And he joined, is it pronounced CalMi squared? Right after graduating in 2015, where he's been developing computational models for various organs and medical devices. He has been involved in the field of FAIR data since 2019, and he leads the FAIR Data Innovations Hub, a division of CalMi Squared, where he and his team are developing various guidelines and computer tools that make it easier for biomedical researchers to make their data and software fair. These include tools such as SODA, which is software to organize data automatically for the NIH Spark program, and FAIR Hub for the NIH Bridge to IA program. So without further ado, I will hand over the mic.
Thanks for the introduction piece. And hi, everyone. I'm Bhavesh, and my talk today is called All's Fair in Love and Software. And of course, FAIR here is all uppercase, stands for findable, accessible, interoperable, and reusable. FAIR is being widely talked this day, mainly in the context of data. And I feel that software is a little bit neglected in that conversation. And as someone who develops computational models and other software, I take that very personally. So I'm hoping we can address that a little bit today and give some much deserved love back to software. And so this presentation will be about 40 minutes long, followed by time for question. And I'm hoping by the end of it, you'll learn why and how to make biomedical research software fair. And the organizer have informed me that I can ask questions to the audience throughout my presentation using Zoom's polling feature. And I've never used that before and got really excited. So you'll see some slides with questions throughout my presentation, and I believe you should be able to answer to them through a Zoom prompt that'll show up on your screen. The answer will be fully anonymous, and they'll be used just to kind of for me to understand what the audience knew before, what they learned during the talk. So if you can please answer, it'll be very useful, and hopefully it also keep you entertained along the way. And I'm so excited about this feature that I already have the first question for you. And so again, you should have a Zoom prompt showing up on your screen. And the first question is, how familiar are you with the FAIR principles? And the options are not at all, I have heard about them, I understand them, but have never implemented them, and I have made or helped make data or other research outcomes fair. And so I'll wait here a little bit, maybe give you all 5 more seconds. 5, 4, 3, 2, 1. Okay. So here. I'll start this talk with telling you a little bit about research software, since this is the main kind of focus of this talk. The widely accepted definition of research software is any software creating during the research process or for a research purpose. So for instance, if you're using Microsoft Excel to analyze and visualize your research data, Excel is not considered a research software. It's rather a software in research. But if you develop a Python script to do exactly the same, that Python script is considered a research software. And so the work I'll present today is built around this definition of research software, although it may apply beyond. And there are many different types of research software. They come in various formats. Typically, when we think of software, we think of, hey, a program that I can install that comes with a user interface and so on, but that's not the case here. Any code that's developed as per the definition I mentioned before is considered a research software. So it can be developed as a Python script, an R code, a Jupyter notebook, a desktop software, a web app, and so on. And they're typically developed for various different applications. It could be developed for data analysis and visualization. It could be developed for computational modeling, for AI and ML modeling, and so on. And so I now have the next poll for you. So again, please respond to the Zoom prompt. Before today, did you know what a research software was? And the options are yes, no, and actually sort of, I don't see that as an option. So just yes or no, you have to decide. You cannot hesitate here. And again, I'll give you a little bit of time here to answer. I think you have the wrong poll here, I think, but that's one that comes later on, I think, piece. I'm not sure if you can change that or, oh, anyway, you'll be a little bit ahead of the of the game. Okay, I'll continue here. And so why are we talking about research software today? It's because it is an essential element of biomedical research. More and more biomedical research projects include development of research software. So as you can imagine, there's code developed in most of the project these days, either to analyze data, clean up the data, curate data, and so on. And in fact, research software is now the main outcome of many research projects. The main goal of many projects is to either develop a computational model or AI and ML model. And data collection is typically in those projects secondary or even non-existent. And here I have a little link of the Research Software Alliance where you can find more evidence on how important research software is and how this importance has increased over the year. And because it is an essential element of biomedical research, sharing and making it reusable is critical. Just like data, sharing software can enable reproducible, transparent research. So if I'm sharing my data but not sharing the code, software developed to analyze the data or process the data, others would not be able to reproduce my results. And in many cases, if I just share the data without the code, it would likely not be reusable. Then sharing software can also prevent duplicate efforts, especially if it's a computational model or an AI model and so on. Sharing it and making it reusable can allow others to reuse it, but also build on top of it rather than starting from scratch. And of course, all of that can increase the pace of discoveries to improve human health. And if you're still not convinced, there might be soon some policies that require sharing and making software reusable from funders such as the NIH. You may know that last year, the NIH imposed a new data sharing policy that requires, for instance, to have each proposal to have a data management and sharing plan, and then to comply with that plan if your project is funded. There is no such strict requirement yet for software, but it may come soon. For instance, just earlier this month, a request from information from the NIH was closed where they asked the community what are their practices for sharing NIH-supported research software. So we can imagine that they might use these responses to this RFI to develop a new policy or at least a more stricter recommendation for sharing research software. And this is the poll I have in which actually you already responded. So should I just move on, please?
I think they're switched, so let me go ahead and do the other poll.
The next one, or should I just keep going since they already have? Maybe you can not have that.
The two were switched. So.
Oh, okay.
Yeah.
Oh, we're a little ahead then. Would that be the case for the rest? Or maybe we can skip one and then have the other one towards the end. That's not sure. But anyway, I'm soon going to talk to you about the FAIR principle. And one question I had after that is, for FAIR principle for research software, actually, that I'm going to talk about soon. And the question I had is, how familiar were you with the FAIR principle for research software, which, as we'll see as I talk, are different than the FAIR principle that were mostly applied to data. Okay, great. I think there's been some answers in, so I'll probably continue now. So through the polls, actually, you'll have a little insight into the future, actually. So that's great. And so, so far, I've told you about what biomedical research software are, how essential they have become in research projects, and how it's critical to make them reusable, just like we're trying to do with data. And so then the question is how to make research software reusable. And we came across these questions with my team as we were developing a software that helps make data reusable. And we started thinking, hey, maybe we should also think about making our software reusable so others can use it, modify it, or even continue working on it if we were unable or unwilling to continue working on it. And as I mentioned, since I'm also developing computational models and other software, I got interested in this question and we started looking into it. And the first thing we found were, of course, the FAIR principles, which are really the gold standards when it comes to making all research outcomes reusable. They were published in 2016 and were established to optimize the reusability of all digital research objects, including software. So although they are used mainly for data, in the original paper, you can see that they are developed for all digital research objects. And maybe to provide some background, the FAIR principle were kind of the outcome of a large worldwide effort from all fields of research, from all stakeholders, including researchers, funders, scientific publisher, who all came together and established these 15 principles that would help optimize the reusability of research objects by humans and machine. And I'm listing some of those principles here. For instance, metadata are assigned a globally unique and persistent identifier. Data are described with rich metadata, and so on. And so we thought that, great, all we have to do is apply the FAIR principles to our research software, make it reusable, and kind of be done with it. And when we look for that, we did find some resources that explain how to apply the FAIR principle to software. But what we found mostly is that many in the research software community found that the FAIR principles as is were not suitable for software because they did not take into account certain specific aspect of software that's different than data. For instance, software has different level of granularity from code snippet to code file, software package, installers, deployed app, and so on. Software also have typically many dependencies on other software, which is not the case with data, as it comes really as a standalone element. And software has also multiple versions over time, which at a more higher frequency, at least, than data. And so all of those members of the community who found the FAIR principle to be not suitable eventually came together and formed what's called the FAIR4 software, or FAIR4RS working group. And it involved over 200 stakeholders all over the world who work on over a couple of years between 2020 and 2022 into adapting the FAIR principles for research software. And the outcome of their work were the FAIR principle for research software, or FAIR4RS principles, published in 2022. These are a set of 17 principles that are aimed at optimizing the reusability of research software. And again, I'm listing a few here. For instance, software is assigned a globally unique and persistent identifier. components of the software representing levels of granularity are assigned distinct identifier, and many more like that. As you can see, some of them are really similar to the original FAIR principle with just the word software swapped in for data, but others have been newly introduced and so on. And this is the poll you already answered, so I'm going to skip through. And so we thought, hey, we found those FAIR4RS principles. It's exactly what we wanted. Let's just apply them to our software, make it reusable, and kind of be done with this. But it was not that easy because the FAIR4RS principle by design do not provide actionable instructions. Just like the original FAIR principle, they are supposed to be very high level, aspirational, and such that they don't change in time. But the challenge was that we had many questions on how to implement them. For instance, how do I assign a unique identifier for my software? How do I provide rich metadata and so on? And we had a lot more such questions. And we came to the realization that, hey, we would have to find those answers by ourselves because they were not available, and derive some guidelines that help us make our software fair. And this is what we did, and the outcome of that effort were the FAIR Biomedical Research Software, or FAIR BioRS guidelines I'm going to talk about now. And so the FAIR BioRS guidelines are minimal, actionable, and step-by-step guidelines for complying with each of the FAIR4RS principles. They're designed to be very specific into telling exactly what you need to do into a step-by-step process, so that once you do that, you will be complying with all 17 of the FAIR4RS principles, and then you can call your software FAIR. And we started this work around December 2021, and then we reached a major milestone August last year when the manuscript on this effort was published. And before I walk you through the guidelines, I'll tell you a little bit about how we established them. And so our first step was to derive high-level instructions for fulfilling each of the FAIR4RS principles. So what we did is we took each principle. For instance, the first one, software is assigned a globally unique and persistent identifier. We read thoroughly the two resources published by the FAIR4RS working group on those principles, and tried to extract from them more information on how that principle could be fulfilled in practice. And then once we found those instructions, we summarized them. For instance, we found that to assign a globally unique and persistent identifier, we can share the software on a repository or a registry that assign such identifiers. So we were getting a little bit closer to understand how to fulfill that principle. And so we repeated that for all of the 17 principles. And what we realized that there were some overlapping theme across the instructions. For instance, sharing software on a repository or registry was also valid for providing rich metadata, since the repository and registry typically ask you information about the software before it's archived or published. And so that helped towards also having metadata that makes the software findable and so on. And so then our next step was to combine the instructions from those 17 principles into categories based on common theme, and we identified 5 of those. 1 was develop software following standards and best practices. 2 was include metadata. 3 was provide a license. 4, share software in a repository. And 5, register in a registry. After establishing this category and classifying the instructions within them, we defined outstanding question we still had for fulfilling these instructions from each category, because despite having those more actionable instructions, it was still not very clear how to implement them. For instance, for category 4, share software in a repository, we had questions such as what repositories can be used for a research software? And in what format should the software be shared? Should we share the source code, the compiled version, and so on? And so we had this long list of still outstanding questions. And then the next step was to find out answers for these questions. And we did that mainly through three approaches. First, we reviewed relevant literature. So we look for papers, articles, online guidelines, and so on. We could find to answer questions about what repositories are suitable for software, what metadata should be provided in what format, and so on. And so this included, for instance, the NIH best practice for sharing research software, several papers on documentation and on best practices for managing software. We also found some universities pages where they had some guidelines for researchers on how to share software. So we combine all of that to find answers for our questions. For some of them, we found that there was a lack of community agreement, for instance, on what metadata format to use and so on. And when that happened, we used our own assessment to define an answer so that we don't leave it open-ended. And based on our experience and understanding of research software, and I'd like to mention here that we have Hervé Ménager as a co-author on this work, who has a tremendous contribution. He's the lead of the Elixir tools platform, where Elixir is the European Union's infrastructure to increase the impact of life science. So we were able to combine some of the work he was doing in his side with his team and knowledge, and kind of bring all of that together into answering those outstanding questions. And finally, we made sure to get external feedback from the community through conferences, webinar talks, discussing with colleagues, and so on. And one of our most fruitful outreach effort was probably at the Bioinformatic Open Source Conference, BOSC, where we were back-to-back in 2022 and 2023, presented the guideline to talk, poster, but we also were able to have the FAIR4RS guideline as one of the topic of the hackathon they have over 2 days before the conference. So that was a great opportunity to interact directly with experts of the field, brainstorm with them, and it really helped improve the guidelines. So once we had all of the answers to those questions, we knew what repositories should be used, what metadata should be provided, in what format, how license should be included, and so on. We organized that into kind of a step-by-step guidelines that follows the typical software development chronology, so they're easier to follow, and that kind of gave birth to the FAIR4RS guideline as they are now. And now I'm going to walk you through these guidelines. The easiest way to access them and also get some background information and resources related to this work is through this website we have called fairbiors.org. You can find, as I mentioned, some information about why these guidelines were needed, how they were developed, reference to our paper, and so on. And of course, you have the guidelines here. As I mentioned, they're organized into a step-by-step fashion. For each element, we made sure that we have very specific information and then also point to external resources whenever we deem necessary. And so the first couple of guidelines are to be followed prior to the development of the software. So the first one is to select a version control system platform to work from, such as GitHub, Bitbucket, or GitLab, and create a repository there. The second step is to select the license. And because this is a very complex topic, especially for researchers like me who are developing research software but not formally trained in software development, we made sure to have a very thorough guidelines for license inclusion. So we mentioned that, hey, the license can be included in a file called license using plain text or markdown syntax. That file can be located into the root directory of the software. We also specify that while the FAIR4RS principle do not require software to be open source, it is highly recommended to use a license approved by the open source initiative. And again, for researchers who really don't have much understanding or license, all they want is to make it available as broadly as possible. We also explicitly encourage use of the permissive MIT or Apache 2.0 licenses, and also point to resources such as chooselicense.com, and also mention that during development, ensure that the software's license is compatible with the dependencies, and that's why you want to select the license at the very beginning. We then have some guidelines about to follow as you are developing the software. For instance, have code level documentation such as in-code comment, record dependencies as per standard practices for the coding knowledge, like requirement.txt file for Python code, follow language-specific standards and best practices such as PEP8 StyleGuide for Python, and then ensure that the input-output of the software follow applicable community standards, and we point to FAIRsharing.org for finding relevant standards. We then have some instructions for documenting software. We suggest to maintain the documentation in a README. And then for more complex software, more sophisticated documentation can be developed using tools such as GitHub Pages or Read the Doc. We made sure to include what some of the requirement or content that should be included in the documentation to comply with the FAIR4RS principles. So it's easier for anyone preparing to documentation to know, hey, at the very least, this is what I want to provide if I want my software to be fair. And we also have some instructions for documenting changes between software in a standard format. The next section we have is on including metadata file, and during our research and work, we found that there were a couple that are suggested. One is codemeta.json and one is citation.cff. And because there's no consensus yet on the within the community, we suggest to include both. As in the FAIR principle, it's always mentioned to include more than less. And so here, this is what we suggest for both of them. We make sure to specify again what fields should be mandatorily provided to align with the FAIR4RS principle. So those are easier to identify, and you can always provide more if you deem that's necessary. The next section is about sharing on a repository that I have mentioned a few times. So we have that in 3 steps. First, if applicable, share the software on a deployment repository such as PyPy or Conda for Python package. Next, we suggest to share the software in an archival repository such as Zenodo or Figshare, which are the 2 we found were the most commonly suggested or used for sharing or archiving research software. And we also again specify that the source code should be shared with all the metadata file mentioned above, but then executable and sample input and output should also be included if available. And this step should be repeated for each version. And finally, we suggest to archive the software repository on Software Heritage, which is a very unique a repository very designed for specifically for a software, and it provides a unique identifier to all level of your software, from code line to code file and so on. And so it helps tremendously in complying with the FAIR4RS principle. And finally, we suggest to register the software on bio.tools registry, or alternatively or optionally also on the research resource soft identifier portal, the RRID portal. So if you follow all of those steps, your software will be compliant with each of the 17 FAIR4RS principle. And the way to use these guidelines, of course, the FAIR principle do not cover everything. They don't go into security, privacy, and so on. So in your software management plan or process, you would have things that you would do for security, privacy, and so on. But when it comes to sharing and making the software reusable, you can just follow the FAIR Bio-RS guidelines as is directly. And we also provide here a crosswalk with FAIR4RS. So one thing I see often is claimed that, hey, this makes your software fair, or this tool will make your software fair. But one thing I don't see is a clear documentation on how that happens. For me making data fair, for instance, would mean that I would comply with each of the 15 FAIR principles. And here for software, it means complying with each of the FAIR4RS principles. So we made sure to document that so that you know for each principle how you are complying to them through the FAIR4RS, FAIR-BioRS guidelines, sorry. So for instance, for the first one, software is assigned a globally unique and persistent identifier. We tell you that archiving the software or Zenodo or Figshare in step 5.2 will assign a digital object identifier or DOI, which is a unique and persistent identifier. Archiving the software on software heritage would also assign a unique identifier, the SWHID, which is also a unique identifier, and bio.tools, the IRRID portal, we do the same. So you will get identifier at different level of your software. And so this first principle is complied through the FAIR-BioRS guidelines through different steps, and we repeat that for all of the FAIR principles. We're also in the process of adding other popular or known guidelines or best practices to compare them as well with the FAIR4RS principles. And for instance, we have here the NIH's best practices for sharing research software. They were established before the FAIR4RS principles were published, so you can imagine they don't comply fully. They comply with some of the FAIR4RS principle, but for some of them, they only help you comply partially, and some of them are not even considered in the NIH's best practices and so on. And you can find other resources. There are some examples on how that are of examples of software that are made fair. For instance, here we have the code, the Jupyter notebook that we developed for processing our review data in this work when we established the FAIR-BioRS guidelines, and we made sure to make that Jupyter notebook fair as well. And so you will see here that we have a README with all the elements we mentioned. There's a code meta.json file, citation.cff file. The dependencies are recorded in the environment.yaml file. It's archived on Zenodo and so on. And so coming back to the guidelines now, you may ask, great, we have those guidelines and they can be followed step by step, but why should anyone kind of bother to go through that? And it's because just like sharing data, sharing software benefits everyone, it's very clear that they benefit reusers of software, so they'll find software more easily, they'll be easily reusable, higher quality, well documented, and so on. But it can also, if you're a researcher developing software, making your software fair with the FAIR-BioRS guideline can also benefit you. And so the FAIR-BioRS guidelines are meant to increase the findability, reusability of your software. So it's more likely that it'll be reused by another project and hopefully contribute to their project as well. So it can increase the impact of your software. The guidelines are also designed to make it easier for others to cite your software. So you get a DOI through Zenodo. There's a citation.cff file that makes it clear for others how to cite your software, so you can get recognition for your development effort. And altogether, this can increase also opportunities for collaboration with others. And this is also beneficial to funders. So if you're funding a software and it's made fair and help another project, it can increase your return on investment. And of course, if you have software that's kind of preserved well over a long period of time without requiring the original developer of the software, it's more likely that it'll be reusable in the future, and you can avoid funding duplicate development efforts. And we still agree that implementing those guidelines can still be a burden, especially for researcher. We are already asking them so much, and then we tell them, hey, make your data fair. Now we tell them, make your software fair. And I experienced that firsthand. This is why I started this work on developing tools that makes it easier for researcher to make their data fair, and started this Fair Data Innovations Hub for that. And one of the software we are developing is called FairShare. It's built to make it easier for researchers to make their immunology-related data fair. And our work actually on the FAIR BioRS guidelines and FAIR software started when we were working on this software. And this is when we started thinking about, hey, let's make this FAIR as well, and so on. And so what we did in FAIRshare is we have included a workflow that helps you make your software FAIR and implement the FAIR BioRS guidelines. And so FAIRshare is a desktop software cross-platform. You can install it on Windows, Mac, or Linux. It's open source and free, like everything we develop in my team. You can find it at docs.fairshareapp.io. And when you install it and open it, it'll have a workflow that takes you step by step into checking that everything you have in your software is compliant with the FAIR4RS principle, but also generating some of the things automatically. So I'll show you a few of the interfaces for here. When you start here, you'll be asked if your software is on your computer or on GitHub. If it's on GitHub, we have more integration, so it automates a lot more. But you can also have it on your computer if you're downloading it from another platform than GitHub and so on. We have interfaces where you can provide all the information about your software conveniently that will be then used to generate the code meta.json and citation file. So you don't have to prepare those manually. We have an interface for selecting a license easily and including a license file. We're also integrated with Zenodo and Figshare, so you can push your software and archive it directly there from FAIRshare. And so then what's going on right now? And as I mentioned, we have published this manuscript last August, but the work didn't stop there. We are currently continuing to promote the guidelines whenever possible, and that's what I'm here. And I'm hoping we are doing a good job, although slowly, but I've seen these guidelines being used in many NIH funded projects, including some major ones. FAIRshare has been downloaded, I believe, over 11,000 times now. So we are hoping all of that indicates that the guidelines are slowly being used in the community. We're in the process of setting up a working group to review the guideline periodically. So if there's anything that changes, for instance, let's say, I don't know, Zenodo shuts down tomorrow, or now the community has agreed on what metadata file to use and so on, then we can update the guidelines accordingly. And although I mentioned we have FAIRshare, it only helps at the end when you are ready to share your software. But the FAIR, making your software FAIR really starts right at the beginning, like I mentioned with the guidelines. So we're in the process of developing a GitHub app that automates even further implementation of the FAIR BioRS guidelines. So if you're working from GitHub, all you'll have to do is give permission to this app, and it'll act like a little assistant bot where it'll submit as you're working and changing your code. It'll make suggestions, open issues for you to tell you when there's something that's required for you or missing to comply with the FAIR principle, help you archive your code when you make a release on Zenodo and so on. And you may be thinking, hey, why this took so long to establish the guideline, and then, hey, why there's also still so much to do. And so I'd like to mention that this work was practically done without any support or funding. We started this as kind of a side quest of a project we were working on, as I mentioned, but this has really been done just by us wanting to kind of establish these guidelines and make them available so others don't have to go through our process of doing this whole literature research and community outreach and so on to kind of have very clean, easy to follow guidelines for making their software fair. They were hoping now that there'll be a more focus going forward on software that will realize that, hey, data is great and we should share it, but the software that comes with it should be shared as well. So we're hoping we'll get more support for this in the future and be able to make more effectively make progress. But in the meantime, I'll tell you how all of you can still support this effort. And so if you're a researcher developing software, you can simply follow the FAIR BioRS guideline, use FAIRshare for support, and reach out to us with questions, suggestions, or feedback. That would be really helpful. If you're a librarian or someone who otherwise support research, if you don't have some guidelines at your university for managing software, you can establish some and include the FAIR BioRS guidelines. If you already have such guidelines, maybe you can update them and include the FAIR BioRS guidelines. And like I mentioned earlier, FAIR principles don't cover all aspects of software management and the life cycle of a software. So you'll have in your little management plan aspect for security, privacy, and other. But when it comes to making software fair, reusable, you can certainly mention the FAIR BioRS guidelines. And being a researcher, I'll be shamed by my colleagues if I was not mentioning about funding. So if there's funder in the audience, you can also help by maybe requiring or recommending to make software fair, just like you're doing with data, and refer to the FAIR BioRS guidelines for doing so. And you can, of course, always support the maintenance of the guidelines and development of more tools through funding, which would help researchers tremendously. I don't think having just policies that imposes making software fair will help. If there's no support, it would probably result in a very poor implementation of fair software, and maybe results also in additional work for the researcher. Whereas if there's automation tools and other support, we can have researcher doing it more broadly and also doing it with greater care. And I have a final poll time for you. There's two questions that you would see. One is, if you are a researcher developing software, will you consider using the FAIR BioRS guidelines? And if in the same poll, if you scroll down, you will see another question that says, if you're a librarian or otherwise supporting research, will the FAIR BioRS guidelines help you in assisting researcher with their software management plan? And I'll give you a little bit of time to respond to this poll, and wait here before I start my countdown again. Okay, it looks like there's still some answers coming in. All right, great. I think we can leave it open, piece, if you like. I think I'm just gonna give a little summary and conclude here. But to summarize, today I provided you some background about research software, explain how now it's an essential element in biomedical research. All projects have some kind of code development that's being done, and then it's critical to make it reusable, make it fair. The problem we identify is there are principles that, such as the FAIR4RS principle, that are specifically designed for making software reusable, but they only provide high-level instructions for making software fair, which doesn't really allow you to implement them in practice. And so the solution we had is we developed some minimal actionable guidelines to make software fair, called the FAIR BioRS guidelines. So if you follow them, you will be complying with each of the FAIR4RS principle, and your software will be considered fair. And all of you can support us already today by, you can promote making software fair, just like data, use the FAIR BioRS guidelines and contribute to them. And I'm hoping that together, let's make sure all's fair in love and software. And with that, I'd like to thank my co-author on this work, Zicheng Hu, Sanjay Sundarajan, Hervé Ménager, and many more. I'd like to thank Peace and Caroline, who have been wonderful in helping with organizing this talk. And of course, I'd like to thank all of you for listening. Thank you.
Thank you so much. This was a wonderful talk. I've learned a lot myself and actually thought of some connections with the work you're doing, and thank you for the work you're doing, just by seeing a need. We are happy to take questions. We have some time, a few more minutes in the webinar, and we can answer any questions that you may have. If you are interested, Caroline posted some of the resources that were mentioned in the presentation in the chat, or you can scan the QR code that is on the screen to find all of the slides and resources that were mentioned in the presentation today. I'll pause for a few minutes, but otherwise, thank you so much for attending. Also, while I have you all, I will go ahead and post, Carol Ann posted it, but I'll post it as well. The evaluation link, please fill that out as you have the time. If you are interested in MLA, continuing education credit, the instructions are provided at the end of the evaluation. Bhavesh, there's a question in the chat, which is, are you familiar with JOS as a place to publish OSS?
Yes, I am. We actually have some one of our software paper in review currently at JOS. Yeah. It was actually something it was actually something we consider as having part of the guideline is to publish about the software, but then through discussion it was decided that that was maybe beyond making it minimal, but it could be an additional step into making your software fair. If there's a paper out there, it'll be easier, maybe more likely to be found by someone. So yeah, definitely as an additional step, and you could consider publishing your software in a journal, and JOS, the Journal of Open Source Software, is an excellent place for that.
I have a question, and I don't know if there's a way to do this, but is there any kind of way or are you tracking how many people are actually utilizing the the FAIR software guidelines that you created?
And not really. I think we have the paper now. It only has one citation, but I think typically people who will use these guidelines are developer of software, so they're not necessarily publishing about their software, so they won't necessarily cite the paper in a way it's counted and shown by the DOI tracking services. It's mostly just through kind of talk. If again we get more support, we want to think about having ways like GitHub badges that you can include in your repository. If you made your software fair, it'll have a little badge that says FAIR4RS, and we can look through GitHub for those, for instance, to see how many are doing that. Maybe if we have the app, we can see how many are the GitHub app we are working on very slowly. Again, this is really side quest, I would say at this point, but we're hoping it'll become a main quest. And definitely, yeah, understanding how many people are using it and so on would be definitely really helpful.
Another question, can your tool be pointed at a repo to validate fairness?
Currently not, but that's also the plan with the GitHub app, because it'll be designed to help you make fair. There'll be validation in it. So the idea is hopefully you can give permission to this tool and it'll kind of evaluate your repository and open issues with things that are missing. So if it doesn't find a license or a metadata file, of the metadata file is there, but not having some of the elements that we thought were necessary for making software fair, you would have that. So currently we don't have any validation tool. We only have, again, the guidelines, some examples that we ourselves have implemented, but hopefully soon. I think I see another question about, is Zenodo a place to publish your software? GitHub repository and make it fair and accessible. So yes, Zenodo is one of the repository we suggest in our guideline. It's the most commonly used repository for for archiving software. I think there's a paper that kind of that we came across during this work, which showed that I think 95% of the DOI that are minted for software are through Zenodo. So it's definitely a major place for sharing software. So maybe just a call. If you want to support, I think, developing tools for validation and so on, please reach out to me as well. We could use some help, yeah.
Okay, I think we can go ahead and close. Thanks again, everyone, for coming. Please fill in the evaluation form that we linked within the chat. Also, there will be a kind of recap email with the slides, the recording, and the evaluation link that will come in the next couple days. So once again, if you've attended other Love Data Week events, we are appreciative of that, and have a great rest of your day. Thank you all for coming.
Thanks.